Hello, class. We're going to continue with chapter 5 here with objective 3. And without further ado, I will get on to the screen share. Okay, so objective 3, discuss theories of color vision and color blindness. So there are a couple of different theories of color vision, actually 3 of them. I'm going to talk about, and you can certainly watch this video. It will give you a good idea of what the after effect is on the opponent process theory. Trichromatic theory is tri meaning 3 and chrome meaning cones. So trichromatic theory says that we have 3 different types of cones, each one that's maximally sensitive to either a short, a medium, or a long wavelength. Well, remember that a short wavelength is blue, looks blue to us, and a longer wavelength looks red to us. And so then the medium wavelength looks greenish, okay? So the ratio of the responses of these 3 different cones determine what color you'll see. And that's one way in which, one theory as to how we see color, 3 different types of cones. Another theory of how we see color is called opponent process theory. And that's the idea that we have these different cells, the bipolar cells, the ganglion cells, and cells in the thalamus, where eventually visual information will go, are excited and inhibited by 3 pairs of colors. So in a single cell, you might get a cell that's excited by red and inhibited by green. So when red wavelengths come in, which are the longer wavelengths, the cell will become excited, but then when a shorter wavelength of green comes in, the cell will become inhibited. And likewise, we have other cells that respond to yellow and blue, and other cells that respond to black and white. And the idea there is that we see color also through opponent process. So it's happening at the level of the cones in the retina, trichromatic theory, but also at the level of the bipolar ganglion and thalamus cells through opponent process. So here you can see trichromatic theory, that these are blue cells. They respond very well to blue color or blue length, short wavelengths. And then these respond to green and these respond to red. They respond best to those. Here you've got opponent process theory. Well, if you have a red, a green, and a blue cone here, the top is trichromatic theory. But then what happens is that you have at the bipolar level, you have cells that are excited by one color and inhibited by another color. And all together, this creates a perception of color in us, those 2 theories combined. And then there's one more theory that's important for color, and it's important for a certain kind of thing called color constancy, and that is the Retinex theory. And this is the idea that the retina combines with the cortex to give us a constancy of color. And that is because when we have variation in lighting, for example, I have yellow curtains in front of me, that might make everything look a little bit yellow in this video because the light's shining through those curtains. But you don't necessarily see me as looking yellow in the video because there's yellow on the lamp back there and there's yellow over here on the walls and everything. And so your brain just subtracts out the yellow because it's everywhere in the picture. There you can see this below. You don't see these things as looking super green. You still see apples as red, even though there's green, there's a green overlay over all of that stuff. So your brain kind of subtracts out a color that's reaching across everything. Okay, let's talk a little bit about color blindness. There are what we call monochromats, that are people with who can just see black and white, and then dichromats. And dichromats are by far the most common. They're mostly men. They're born without a red cone. Remember, trichromatic theory has a blue cone, a green cone, and a red cone. They're born without the red. So what actually they have trouble with is distinguishing red and green. And so when something is green, when something is red, they see it actually as green. So take a look at these and see if you can pick these out. You can see if you are a dichromat. So most people will be able to see 25, 6, 8, and 45 there. Some of these with red and green are more difficult, as you can see. Take a look at this one. We have relatively few blue cones, so this one, it becomes a little bit more difficult because the number there is in blue, but the number is 5. Okay, we're going to talk a little bit about the neural basis of visual perception next, and I just want to go through the structure getting into the brain, and then we'll continue on objective 4 next time. In the neural basis of visual perception, we have, remember, the rods and cones are going to be connected to the bipolar cells, going to be connected to the ganglion cells. That's all happening in the eyeball. But then once the ganglion cells leave through the optic nerve, they're going to go to the thalamus. And particularly, they go to one part of the thalamus, and that's called the lateral geniculate nucleus, or the LGN, we often call it. So here's the LGN, and here's the thalamus. This is the entire thalamus. This just very tiny top point here is the lateral geniculate nucleus. The medial geniculate nucleus is actually for hearing, and different parts of the thalamus are for different kinds of sensory information. Remember that the thalamus is kind of a sensory relay information center. And so visual information goes there, but other kinds of senses do as well. So we see information going from the photoreceptors to the bipolar cells to the ganglion cells. There they leave the eye, they go to the thalamus, and particularly the lateral geniculate nucleus of the thalamus. Okay, I want to talk a little bit about visual pathways. So we have a visual field that is a left visual field and a right visual field. If I look straight ahead, then this is my right visual field, everything over to this side, and this is my left visual field, everything over this side from the middle to my peripheral vision. Now, what's going to happen is that my left visual field is going to go to the right side of my brain. My right visual field is going to go to the left side of my brain. Now, my right visual field is going into both eyes because it's coming in this way, and both eyes get that information, but still it is going to go to the left side of my brain. And there you can see the pathways in red and blue to make that a little bit more clear. Okay, so again, basic visual pathway, we're going to leave the eye, go out through the optic nerve, which is those ganglion cells, go to the lateral geniculate nucleus, and now we're going to swing back and end up in the occipital lobe in an area we call the primary visual cortex there. I'm going to talk a little bit more about receptive fields next time, and we'll leave this one right here.